Metalworking transforms raw steel into precision masterpieces, combining power, heat, and skill to create the backbone of modern industry. The air hammer, in the old Bethlehem blacksmith shop in Johnstown, Pennsylvania, represents impressive industrial heritage. These massive machines require about 700 cubic feet per minute of air at 100 psi to operate, demonstrating the scale of power once essential in heavy forging. Although the hammer is owned by the Smithsonian Institution, it is actively operated today by the Center for Metal Arts, which relocated to Johnstown specifically to preserve and utilize these legendary tools. Their relocation highlights the historical and cultural significance of the hammers as living artifacts rather than static displays. This footage, captured during a public tour in October 2019, showcases not only the hammer's remarkable force, but also its ongoing role in education, craftsmanship, and the continuation of blacksmithing traditions. Free-forging a special piston is a fascinating process that combines craftsmanship, skill, and traditional forging techniques. The operation begins with a heated metal billet, which is prepared to the right temperature so that it becomes malleable under repeated hammering. Once ready, the billet is carefully gripped with long tongs by a blacksmith and positioned under a foot-operated forging hammer. This type of hammer is powered by the worker's foot pressing a pedal, which repeatedly releases the hammerhead, causing it to drop with force onto the hot billet. Each strike compresses and reshapes the metal, gradually bringing it closer to the desired form. At the beginning, the main operator works alone, holding the billet firmly and pressing the pedal continuously. The rhythm of the hammer striking against the glowing billet creates both sound and energy in the workshop, reflecting the essence of traditional blacksmithing. After several rounds of hammering, another worker steps in to assist. This second smith supports the process by helping control the billet's position and ensuring that each impact is evenly distributed. The teamwork allows for more efficient shaping and reduces the physical strain on a single operator. As the billet takes on a rough shape, the blacksmiths proceed to the next stage. The partially forged piece is now strong yet still workable, making it suitable for more precise forming. The billet is transferred into a die or forging mold, which is specially designed to define the contours of the piston. Unlike the earlier free hammering stage, where the shape was guided only by the workers, control and hammer blows, the die provides a structured cavity. This ensures that the forging gradually transitions from a rough block to a component with recognizable piston geometry. The process of striking continues with the billet inside the die. The smith maintains pressure on the foot pedal, and the hammer falls repeatedly onto the metal, forcing it into the mold cavity. Each impact pushes the material outward, filling the corners and edges of the die to achieve the required dimensions. The glowing billet is carefully rotated and repositioned as needed, guaranteeing that no part is left unfinished. By the end of the operation, the once shapeless billet has been transformed into a near net-shaped piston blank. The teamwork of skilled blacksmiths, combined with the reliability of the foot-operated hammer, makes this transformation possible. The piston will later undergo additional finishing processes such as trimming, machining, and heat treatment, but its essential form is already established through forging. In conclusion, the free forging of a special piston demonstrates how traditional hammer forging methods are still effective for creating complex parts. It highlights not only the physical strength of the workers, but also their precision, cooperation, and mastery of a time-honored craft. Bending machines are essential equipment in modern metalworking, enabling the transformation of straight tubes, bars, and profiles into precise curves, spirals, or circular shapes. Among the most recognized brands offers a wide range of professional bending machines designed for different applications and materials. These machines are valued for their industrial strength, accuracy, and adaptability, making them indispensable in various industries such as automotive, construction, furniture, piping systems, and mechanical engineering. Hiu, Mo. One of the most common types is the tube bending machine, which can be either automatic or semi-automatic. These machines are designed to bend metallic pipes, particularly aluminum tubes, into complex shapes such as spirals or coils. In the video reference, a tube is being formed into a helical spring-like shape, demonstrating the machine's ability to handle intricate bending tasks. The main components usually include guide rollers, bending rollers, and a control system that ensures the tube follows the programmed curvature. Automatic models allow complete automation of the process, enhancing precision and efficiency, while semi-automatic ones combine mechanical power with operator adjustments. Apart from tubes, machines also specialize in bending metal strips or hoops. Often used in construction or reinforcement work, these machines can bend steel bars, hoops, or flat strips into different angles and configurations. In reinforced concrete projects, for instance, hoop bending machines create steel ties and reinforcements with high accuracy. Their robust body, integrated rollers or dies, and user-friendly control panels make them versatile tools for both small workshops and industrial production lines. Another category is the profile bending machine, specifically the three-roll design. These machines apply force through three rollers arranged in a triangular layout, allowing the deformation of various profiles such as U-beams, T-sections, I-beams, angles, and hollow tubes. The profile benders are designed for reliability and consistent repeatability, ensuring high-quality results even in continuous operations. They are widely applied in metal fabrication for producing circular or curved elements required in structural, architectural, or mechanical assemblies. COMAC's Galileo section rollers represent a specialized line of industrial machines used to bend tubes, angles, and bars into diverse shapes. Their main features include three powered rollers, a pyramid-style structure, and hydraulic adjustment for precise control. The machine can operate in both vertical and horizontal positions, providing flexibility depending on the workshop's layout and the type of material processed. These machines are particularly suitable for small and medium-sized manufacturers that require reliable bending capacity for standard or customized components. For cold bending of metal bars, it also produces dedicated bar bending machines. These machines are designed to bend steel, stainless steel, and aluminum bars into arcs, rings, and circular forms. Their versatility lies in their ability to handle different cross-sections, from round tubes to flat bars and angular profiles. The advantages of COMAC bending machines are clear. They allow automation of bending processes, significantly increasing productivity and accuracy. The machines are versatile, capable of working with different metals and profiles, and durable, built with industrial-grade materials. Applications span across automobile manufacturing, furniture production, household appliances, piping installations, and construction projects where bent metal components are required. In summary, COMAC bending machines represent a comprehensive solution for shaping metal tubes, strips, bars, and profiles into desired forms. Whether automatic tube benders, 3-roll profile machines, section rollers, or specialized bar benders, these machines ensure flexibility, efficiency, and precision. The HEH high-efficiency heater represents an innovative heating solution based on the concept of taper, designed to provide maximum performance with simplicity and reliability. With an efficiency of up to 85%, it ensures energy savings while delivering consistent results. Its compact dimensions allow easy integration into existing plants, even after gas preheating, offering exceptional flexibility in positioning. The HEH is engineered with independent rotor heating capability, enabling precise billet temperature control in each heating zone. This guarantees both isothermal and taper cycles with outstanding repeatability. Furthermore, its simple technological design minimizes maintenance needs and significantly reduces operational costs. Unlike traditional systems, the HEH requires no cooling water system, power transformer unit, converter, or capacitor banks, making it more cost-effective and easier to operate. Combining high performance, low maintenance, and adaptability, the HEH stands out as a cutting-edge solution for modern industrial heating processes. Plasma cutting is a widely used thermal cutting process that allows precise and efficient separation of metal sheets. In this case, an automatic system is applied to cut steel plates with a thickness of 3 mm using plasma. The process is performed with the advanced thermal cutting machine RUR 3500, which is designed for both oxy-fuel and plasma cutting, including high-definition plasma technology. Thanks to its structural rigidity and dynamic properties, the RUR 3500 ensures high accuracy, repeatability, and productivity in industrial applications. The machine is built with a fully welded frame and a digitally synchronized twin-side motion control system on both longitudinal rails, providing stability and smooth motion during operation. It is equipped with a linear bearing in the cross-axis, a new AC servo drive system capable of reaching speeds up to 12,000 mm per minute, and a modern Pierce 15 inches control system with touchscreen interface. These features enable precise control over cutting parameters and real-time adjustments. Additionally, the RUR 3500 offers a variety of automated functions, such as automatic initial height sensing of the plasma torch, arc voltage height control, and electric ignition. The floating cutting heads and automatic piercing with preheating cycles enhance both quality and efficiency. Safety and durability are guaranteed by limit switch protection on each axis and parking areas for torches outside the cutting zone. For higher performance, optional equipment includes a 19 inches control system, upgraded servo drives with speeds up to 20,000 millimeters per minute, automatic gas consoles, anti-collision systems, and multiple torch parking. Continuous stamping is a high-efficiency process where sheet metal blanks pass through successive dies. Each stage shapes, pierces, or flares the material with precision. This automated method ensures consistent quality, reduces labor, and is widely applied in mass production of complex metal components. The coil slitting and packaging line is designed to handle slit strips with high precision, safety, and efficiency. After the slitting process, the line is capable of picking up slits with a maximum width of up to 1,850 millimeters. The picking system operates automatically, ensuring that the slit coils are carefully separated and transferred for the next stages without any damage to the material edges. One of the key features of the line is the radial strapping system. This function secures each slit coil with strong radial straps, preventing loosening or deformation during handling, transportation, and storage. The strapping process is fully automated, reducing manual labor and ensuring consistent tension for reliable coil stability. Additionally, the line is equipped with an auto-centering and picking system. This advanced mechanism precisely aligns the slit coils before lifting, which not only increases operational safety, but also optimizes stacking accuracy. The automation ensures minimal downtime between cycles and guarantees repeatable performance. The final step of the process involves stacking. The line is designed with 6 stacking stations, allowing slit coils to be efficiently arranged according to size, order, or customer requirements. Each station receives coils in a systematic way, enabling smooth workflow and higher productivity. Overall, this coil slitting and packaging line integrates advanced automation with robust mechanical design. Its ability to perform slits picking, radial strapping, auto-centering, and multi-station stacking makes it an essential solution for modern coil processing plants requiring efficiency, precision, and reliability. The unloading of hot-rolled steel coils from trucks into the warehouse is carried out with precision and safety using an overhead crane. When the truck arrives, the coils are carefully inspected to ensure proper positioning and stability before handling. The crane operator then maneuvers the overhead crane, equipped with a heavy-duty lifting hook or C-hook, to securely engage the inner diameter of the steel coil. With controlled lifting, the coil is raised from the trailer bed, ensuring that no sudden movements occur that could cause damage or accidents. Once lifted, the coil is smoothly transported along the crane track system to the designated storage area inside the warehouse. The operator carefully lowers the coil onto wooden saddles or steel supports, which prevent rolling and protect the surface. Each coil is positioned according to warehouse layout requirements, allowing for efficient space utilization and easy future retrieval. This method ensures that coils are unloaded quickly, safely, and without material damage, maintaining both productivity and quality standards in steel handling operations. The production process of the 650 grass cutting knife with serrated blade combines precision engineering with durable finishing techniques. It begins with blanking, where sheet steel is cut into the required knife shape, ensuring uniform size and accuracy. Next comes quenching, a controlled heat treatment that hardens the steel, improving its strength and wear resistance for long-term use in tough conditions. After hardening, the blade undergoes polishing, which removes surface impurities, enhances smoothness, and prepares it for further finishing. Advanced 3D grinding is then applied to refine the cutting edge and ensure sharpness with consistent geometry. A serration process follows, forming the distinctive teeth on the blade, which improve cutting performance by gripping and slicing grass more effectively. Finally, the knife is fitted with a durable wood grip, providing comfort, stability, and a traditional aesthetic, resulting in a high-quality tool designed for efficiency and reliability. A sheet metal forming press is a powerful machine used to shape flat metal sheets into desired forms. By applying high pressure through a punch and die system, it enables precise bending, punching, or deep drawing operations. This equipment is widely used in automotive, aerospace, and manufacturing industries, ensuring accuracy, repeatability, and efficiency. Modern presses often feature automation and control systems to improve productivity and reduce labor effort. General Devices has been a trusted name in electronic packaging hardware since 1953, offering one of the most complete selections in the industry. Our facility spans over 160,000 square feet of manufacturing space and 16,000 square feet dedicated to R&D, engineering, and offices, equipped with the latest high-efficiency technology. We provide full-service precision metal fabrication, from engineering input and precision cutting to finishing. Our laser machines cut up to 34 inches steel with plus or minus 0.05 millimeters repeatability, while CNC turret presses handle sheets up to 50 inches by 78 inches. Hydraulic press brakes with 175-ton capacity and punch presses up to 500 tons expand our forming capabilities. We also operate a tool and die shop for fixtures and gauges. Additional services include advanced welding, zirconium pre-treatment, powder and wet painting, and custom graphics. Furthermore, we are recognized leaders in telescoping slides of multiple bearing designs. The construction of a chandelier is a meticulous process that combines precision metalworking, careful assembly, and an eye for design. In this episode of The Build, the focus is placed on completing the center section of the fixture, which serves as both the structural core and the main support for the outer decorative elements. The process begins by preparing the rings that were fabricated in the previous segment. These rings are essential because they provide the framework around which the chandelier's form is developed. With the rings ready, attention shifts to the central span, which holds the junction box and the support arms. The junction box is particularly important, as it houses the electrical connections that will eventually power the light bulbs. To ensure safety and durability, the box must be aligned correctly within the structure, with all holes and mounting points precisely drilled. At the same time, the support arms are fabricated and positioned. These arms not only carry the weight of the outer rings and glass or crystal decorations, but also establish the chandelier's overall geometry. From the side, the layout begins to reveal the intended silhouette, giving a preview of the final design. Once the junction box and arms are in place, the builder begins to assemble the parts carefully. Welding or fastening methods are used to secure the arms to the central span, making sure that the alignment is symmetrical and stable. Any imbalance at this stage could affect the chandelier's hanging position and long-term reliability. Careful measurement and leveling are essential. After fastening, the joints are inspected for strength, and any rough edges are ground smooth to ensure both safety and a clean aesthetic. With the structure complete, surface preparation follows. The metal components are sanded, polished, or treated to remove oxidation and prepare them for finishing. Depending on the design, finishes might include powder coating, plating, or painting. This step enhances not only the visual appeal, but also the resistance to corrosion. The junction box may also be fitted with insulating components or protective covers to meet electrical standards. The next task is wiring the chandelier. Electrical wires are threaded through the central span and along the arms, connecting each socket location to the junction box. This step requires accuracy, as loose connections could cause malfunctions or hazards. After wiring, sockets are mounted and tested for alignment. The electrician then checks continuity and grounding to confirm that the fixture is safe for installation. After and RERs. Once wiring is complete, the decorative elements can be installed. Glass shades, crystal drops, or metal ornaments are attached to the rings and arms, creating the chandelier's distinctive look. The symmetry of these components is vital, as even a slight misalignment can disrupt the harmony of the design. The builder steps back frequently to assess the overall balance and make adjustments. Finally, the completed chandelier is tested. The lights are powered on to confirm functionality, and the fixture is hung temporarily to evaluate weight distribution and stability. Minor tweaks are made as needed to perfect the alignment. At this point, the chandelier reflects the careful craftsmanship invested at every stage, from fabricating rings to wiring and decoration. In conclusion, building a chandelier involves a seamless integration of structural engineering, precise metalwork, and artistic design. By methodically assembling the rings, constructing the central span with a junction box and arms, wiring the sockets and adding the decorative elements, the builder transforms raw materials into an elegant, functional centerpiece ready to illuminate any space. After the hot rolling process, the steel sheet coil is transferred to the strapping station, where it must be secured for safe handling and transport. Automatic machines position the coil precisely, and heavy-duty steel straps are wrapped tightly around its circumference. These straps are applied radially and circumferentially to prevent any loosening during storage or shipping. The machines apply controlled tension to ensure the coil remains stable without damaging the material. Once the strapping is complete, the coil is firmly fixed, maintaining its shape and compactness, ready for stacking, storage, or further delivery to customers.